Now, in this video, I am going to explain framing in data link layer because one of the major responsibility of data link layer is framing. How to do it, how we do byte stuffing, how we do bit stuffing. Each and every point will be cleared in this video. Okay, let's start with framing in data link layer. So, what is the concept of framing? These basic points can be asked in the exam for 1 or half marks. So, pay attention. The data link layer needs to pack the bits into frames. Okay, this means the bits that are coming to me from upper layer, I have to convert those bits into frames. Here, what do we use? Frame. In the first lecture of computer network, I had told you about these. Okay, like in the network layer, we call it packet. Similarly, in the data link layer, we call it frame. Okay, now if we want to distinguish different frames, means if we want to separate one frame from another, then for that we basically use framing concept. Now talking about framing here, one of the major technique used in framing is character oriented framing. What does character oriented mean here? We stuff characters in between the actual data. Okay, let me explain with an example. The way character are coming to me, let's say ABCD, this data has come to me from upper layer. Now what do I do with this data? I have to frame these characters. What do we do to frame this? We use flags, like one flag is put at the beginning and one flag put at the end, and then my character come in between, so it look like flag ABCD flag. Okay, look, when the first flag comes and after that when the second flag comes, from this we can understand that whatever character are written in between these two flags, this is our actual data. This is basically the work of framing. Now similarly, many times you can be asked an important question: what happens if there is a flag character within the data itself? Let me explain this scenario. Let's say data comes this way: A flag C. The flag character is actually part of the data, not a delimiter. So if this flag is part of the data, then what should we do? In that case, to distinguish this flag from the actual frame delimiter, I will have to stuff one more character. Let's say ESC, escape character. Okay, I will stuff escape before the flag. That's part of the data. So it becomes A escape flag C. Then I add my frame delimiter, flag A escape flag C flag. Okay, look, this is what we will now send to the receiver. So when the receiver accept it, it sees flag, then A, then escape, then flag, then C, then flag. Okay, if escape comes before a flag, then ignore that flag as a frame delimiter. Consider that flag as data instead. The receiver will only consider a flag as a frame delimiter if there is no escape before it. Okay, so the first flag and the last flag are the actual frame delimiter, and everything between them is data. This is the basic fundamental concept. What if escape is in the data? Now here's another scenario. Okay, what if the escape character itself comes in the data? Then before that escape we will put one more escape. Okay, we will stuff it. So if the original data had an escape, we make it escape escape. Okay, this way the receiver will know if there are two escapes together, consider the second one as actual data. If a flag comes in the data, then before that flag an escape is stuffed. If an escape comes in the data, then before that escape another escape is stuffed. Now similarly we can do this in bit oriented framing. In byte framing we stuff entire characters, but we can do it bit stuffing also. Bit stuffing means if data comes to me like 0111110 and I am using a specific bit pattern as my frame delimiter, then I need to ensure that this pattern doesn't appear in the data. Okay, let me explain bit stuffing with a common example. In bit oriented protocols we often use the pattern 0111110, 0 followed by 6 ones followed by 0 as our flag or frame delimiter. Okay, now what's the rule for bit stuffing? If 5 continues 1 appears in the data, we stuff 0 after them. Why we do this? Because we want to prevent the accidental occurrence of flag pattern in the data. Okay, see what happened when we encountered 5 consecutive ones, 01111, we inserted a 0 after them, making it 0111110. This break the potential flag pattern. Okay, why do we specifically stuff after 5 ones? Because our flag pattern is 0610, 6 ones between two zeros. Okay, if we allow 6 consecutive ones in data and if they happen to be preceded and followed by zeros, it might be mistaken for a flag. So the rule is whenever the sender sees 5 consecutive one in the data, it inserts a 0 after them. The receiver knows this rule. So whenever it sees 5 consecutive ones followed by 0, it removes that stuffed 0 to get back the original data. Okay, but if the receiver sees 6 consecutive ones, specifically in this pattern, it knows this is a flag, not data. Okay, this way we can clearly distinguish between actual frame delimiter and data that might accidentally contain similar patterns. Okay, this is bit stuffing. That was whole concept of framing. Okay, that's it for this video. We will meet in next video. Until then, bye bye.